We present headEyeK, a framework to study gaze behavior in VR, and an algorithm to produce realistic head and eye motion from a time sequence of gaze targets.
Existing head plus eye motion control methods treat each gaze shift as an independent motion, ignoring intended gaze dwell times or anticipated gaze shifts. These methods tend to either over or under articulate the head for a number of common gaze patterns. Double looks and alternating gaze behavior, like watching tennis, are good examples of problematic scenarios. We designed a framework and experiments to study the head and eye motion of such gaze sequences in VR.
To communicate dwell time, we designed targets with a clear progress bar, with the size of the target corresponding to expected dwell time. To elicit anticipatory behavior, we display green indicator to point to the next target. These targets are employed to collect data for a diverse set of gaze patterns.
Our experiments provided useful insights. A positive correlation between head motion and intended dwell time on a target. A tendency for the head to move toward a given gaze target while also being drawn towards an anticipated target. A tendency to combine the head motion for gaze targets that are close in space and time. Based on the insights, we propose two new forms of energy to minimize: eye strain energy and locomotion energy.
While eye strain energy captures the tendency of turning the head toward the current and anticipated future gaze targets, locomotion energy captures the need to be efficient, turning the head only for prolonged gaze. By minimizing both energies, we obtain realistic head angle for each of the N-gaze shift. We solve the optimization problem with a graphical approach. Based on the input gaze sequence, we construct an N-layer graph, where nodes in each layer discretely represent the potential head angles towards gaze target N. By storing E-target in the nodes and E-transition in the edges, computing the shortest path through the graph would minimize the optimization problem and produce the plausible head rotation toward each gaze shift. With the graphical formulation, it is possible to author different gaze behaviors based on the same input sequence. For example, by constraining or fixing the range of head angles on certain layers. Different styles of gaze behavior can be generated. For a real-time version of the algorithm, a windowed approach can be used to construct the graph layer by layer and greedily solve for the optimized head angle by considering only the next layer, or K-layers. The real-time version is an approximation of the full method. By increasing the size of the look-ahead window, the performance would approach the full model. We can see that with 3 look-ahead targets, the model's performance increased dramatically. Our evaluation is threefold, including quantitative comparison against prior arts, a perceptual study, and various rendered animations produced by our system. For quantitative comparison, we recorded head-eye coordination data during various challenging gaze behaviors in VR, and compared 8 different prior methods against the proposed method in terms of mean square error. Our proposed method has achieved the lowest error amongst all prior works. We've also conducted a perceptual study for the different methods, where users are asked to rank the generated gaze animations. In addition to double take and tennis condition, we've also included motions with smooth pursuit behavior, such as observing juggling and reading. Prior works without smooth pursuit functionalities are animated by first generating discrete gaze targets using a dispersion filter, then performing gaze shifts through the targets. Our preference study has shown that the viewers generally prefer our method over prior works, We conducted an analysis using the Placket-Luce model and showed that viewers are at least 4 times as likely to prefer our method over any other. Lastly, we present how our animation system can produce convincing complex conversational gaze.
What on God's green earth are you doing?
A letter.
Looks more like a piecemeal ransom note.
May I?
Dear Dolores, DEAR, this is an animal. I'm meeting all the highly leading citizens of the town.